Hi, everyone. Good afternoon. I hope you all have had a great day. Um, how are people disliking the video before we even start? I'm failing to understand what's going on here. But anyway, let's go ahead and get started. Now, I just wanted to let you know, let me adjust this so that this is somewhat straight. What we're going to be doing today, just so you are aware, I'm going to be doing an introduction to our class. I'm not going to be doing the lab. The lab I'm going to record and post separately because it requires more than one person to do it. But before we do the lab, I do want to give you some information on wavelength. So if you can just kind of give me a thumbs up, a hello, a wave, something, just let me know that you're there and that you can hear me so that we can get started. And we will go from there. Hey, Esteban. Hey, Aaron. Okay, so you guys can definitely hear me. We're going to talk about, hi, Kaylee. We're going to talk about wavelength and frequency today. It's going to be a little bit technical, so you may need to actually watch this. Hey, Sabrina, Miranda, Ryan, good to see you guys. I'm glad you guys are on. You may need to see this more than once. And it's because it's a little bit on the technical side, but I'm going to try to explain it as clearly as I can. So we're going to talk about wavelength, frequency. Hey, Sam, Alexis. Awesome. All right, so we're going to talk about wavelength and frequency, and I'm going to give you guys some definitions and stuff. I'm not going to write out all of the definitions, but I'm going to draw a picture that'll help you understand what it is. Okay, so if you look at a wave, okay, and if we have a line, let me grab a ruler. If we have a line for the wave that depicts the center of the wave, okay, so this line here is basically kind of like the center of the wave, and I'm going to draw this as best as I can, okay? And I'm going to use a different color marker. So if you have a wave, okay, slightly off, but I'll work with the part that's pretty good. So from this point of the wave to this point of the wave, in other words, any point on a wave to that exact same point on the next wave. Okay, so this is one wave. From here to here is one full wave. From here to here is another full wave. So I have two full wavelengths here. Okay? Now, this is called a wave length. Okay? Now, this part of the wave right here, and I'll do that in a different color. This here, the highest part of the wave is called a crest, and the lowest part of a wave is called a trough. Okay, now a wavelength can be measured anywhere. I chose the top because it's the easiest point. I could say from here to here. I could say from here to here. Okay, I could say from here to there. But it's easier to pick a point where the wave is. Okay, from the one point either at the top or at the line. Okay, so when from here to here, for example, the beginning of this wave to the beginning of the next wave. Okay, now, so you have your crest and you have your trough. And then, and I'll go for a different color, you have your amplitude. Okay, that might be a little bit too light. Your amplitude is the entire height of your wave. Okay, so that is the amplitude of the wave. Okay, so is everybody with me so far? Okay, now, so to explain what the amplitude is, it's the total displacement of the wave or the total height of the wave. Okay, so that black line that I drew initially, that is the pretty much 0.0 of the wave. In other words, if there was no wave happening, that would be 0.0. Okay, that's where everything would be. And as the wave starts to occur, it displaces all the way up here and all the way down there. That is the amplitude, the maximum displacement going up and going down. So it could be like this, or it could be like this. Okay? Now, let's get a little bit technical. You have your frequency and your wavelength. So I talked about wavelength, which is this point to this point. So one point on a wave to the exact same point on the next wave. Okay? But the frequency of a wave changes if the wave is moving faster or slower. So for example, if I have a wave that looks like this, it has a lower frequency than a wave that moves like this. Okay? This frequency is much, much greater. In other words, if let's say I have a point, and let's say it's from here, where I'm standing here, to here. Okay, so I'm looking at my floors of measurement. I know you can't see it, but that is 3 full tiles. Okay, so in this particular case, if I'm able to get 2 full wavelengths, okay, in that group, then we're in that space, then you're talking about a relatively slow frequency. If we're talking about in that particular span, I can get, as we're moving from point A to point B, 5 or 6 different wavelengths. So now instead of it looking like this, it'll probably look like, okay? In that particular case, this has a greater frequency. In other words, how frequent does a wave pass a particular point? So if I have a wave starting here, and I have one, so we're going from here to, let's say, here, and I get to this point and I have 2 wavelengths pass versus 5 wavelengths passing, then this wave is moving slower than this wave. Okay, and you'll notice wavelengths that tend to be moving slower have larger crests and troughs. Wavelengths that tend to be moving faster have shorter crests and troughs. So you'll go from this to, does that make sense? Okay, just kind of giving you the basics of what they look like. Yeah. Awesome. Okay, so having gone through that, let's talk about formulas. Okay, and I'm not going to bore you too much with the formulas, but it's good to understand what they mean. So, okay, when you talk about frequency, frequency of a wave is the number of complete waves that are produced per second. Okay, so if you have, you know, okay, now frequency is measured in hertz. Okay, I'm sure some of you have heard of that, and I don't mean hertz rental car, I mean hertz. Okay, it's a measurement of frequency. And since frequency is the number of cycles per second, it is equal to the inverse. Okay, the period is the inverse of the frequency, and we're going to talk about period for 1 second. So T is time, is the time period in seconds, and F is the frequency in hertz. Okay, so time is equal to 1 over the frequency. Okay? I'm sorry. I'm getting ahead of myself. I apologize. Oh, no. I was right. I'm sorry. I'm really starting to get ahead of myself. So 1 over the frequency. Okay, so time is equal to 1 over the frequency. The faster it's moving, okay, the greater the frequency, the shorter the time span. Okay, that's basically what that translates to. Now, I don't know that you're going to have to use these formulas, but it's good to understand them, because if you don't understand them, then, you know, when we get on to high school, you might have a little bit of a problem. Okay, so for a sinusoidal wave moving at a fixed wave speed, frequency is inversely proportional to the wavelength. Okay, this is what you need to understand, and this is what I just finished explaining to you, but in a formula. Okay, so your frequency is inversely proportional to 1 over the wavelength. 1 over the wavelength, and the wavelength here is symbolized as lambda. Okay, so what this says is basically, if your wavelength is smaller, if this number is smaller, 1 divided by a smaller number is going to give you a greater frequency. Think about it. 1 divided by 2 is 0.5. 1 divided by 5 is 0.2. 0.2 is a smaller number. 0.5 is a bigger number. The frequency will be moving faster. Okay? So, if you were to divide 1 divided by 10, it would be 0.1. So with a wavelength, if you have a wavelength of 10, you have 1/10. Okay? That is smaller than 0.2, and at the same, so your frequency at that point would be the lowest. Okay, so the greater the wavelength, the shorter the frequency. Okay, so the faster something is moving, the shorter the wavelengths. The slower something is moving, the bigger the wavelength. That's pretty much what they're trying to get you to understand here, and that's just a formula that represents it. Okay, so things that you should understand: wavelength, frequency, amplitude. You should know what a crest and a trough are, and you should understand how to measure a wavelength. And when we do the lab, so when I do the lab, and I'm going to physically go through the measurements, and we're going to have to use the wall and everything, so I have to make some changes here. But when I do the lab, you're going to see how I'm making measurements, and as I'm making these measurements, you're going to be able to see that the faster something is moving, the shorter the wavelengths are. The slower something is moving, the larger the wavelengths are. Okay, so it's making sense. Okay, I'm glad to see that, you know, it's helping you out a little bit. Does anyone have any questions? Anything you want me to go over? Okay. So when you measure a wavelength, you measure in a meter. Okay, so when I measure it, when I do it, I'll measure it in centimeters, and I will convert it. Okay, I will take pictures of the book. Okay, I'll take pictures of the book. First of all, it shows you pictures of wavelengths. It'll show you what the data table is supposed to look like, which I will also post up here. And I will, you know, explain in the lab after I collect the data anything that you need me to help you with, so that you would understand it a little bit better. Okay. But does anyone have any questions? I know it's a lot shorter than normal, but I didn't want to try to attempt to do the lab with all the movement that's going to happen. I wanted to at least get the specifics of wavelength, frequency, amplitude, what displacement looks like, so on and so forth. So if you're good, just say yes. If you have a question, please let me know. I will do the lab today. I know I have to post yesterday's assignment, and today I will post, once I get the video posted between today and tomorrow, then I will post the associated assignment. I want you guys to get the video too. Okay. I'm glad you guys understand it. This is actually a really cool unit. It's just, I wish you could actually physically do it. It breaks my heart that you can't. But hopefully my explaining it and showing it to you and doing the labs will help you a little bit better. Okay. There are a lot of pictures to the analysis questions. Now, I do have a question for you, and I want to get your feedback. On the last assignment where I posted it, embedded inside the assignment, there was an attachment that had the copies of the pages for you. Were you able to see that? Because what I can do is just post them as a separate attachment altogether and not attach them to the assignment. I just thought it'd be easier to keep everything in one central location. But are you able to actually physically see the attachments? So basically that test that I give you. All right, so I'll post it separately, but you guys should also, if you can, use the website, but I'll post the pictures separately. Okay, it won't be embedded in the assignment, so it'll say activity 98 pages. But I want you to see all the pictures that are in it, and I want you to see what the setup looks like, even though I'm going to physically perform it. Plus, with the questions, I'll post the questions, but there are a lot of graphs as well. Okay. All right, guys. So unless you have any questions, and I apologize for yesterday. I know I was going to stay behind, and I was in the middle of typing something, and for some reason, the whole screen closed out, and I couldn't get back in. So I'm sorry. My bad. I was in the process of sending you a note when it shut down on me. But I'll stay behind if you have any questions. And if you do, I'll give it a couple of hours. That way, if there's something you want me to go back and explain, I can explain it in the video. If not, I can go ahead and just do the lab, and we'll go from there. So, like I said, I'll stay behind in the stream, but I'll stay in the chat room for a moment or two to see if anyone has anything to say. But if not, I hope you guys have a wonderful day. Today's Thursday, so there is no class tomorrow. Make sure you get your test done. I will post the retake Monday morning, give you guys a weekend to breathe. I'll go over activity 89 on Monday, and we'll talk about the lab a little bit, make sure you understand it and answer any questions you have. So if you come in a little bit early Monday, do me a favor. If you have a question, post the question. That way I can look at it and prepare to answer it for you. Okay? Have an awesome weekend, guys, and I will see you on Monday. Bye.